All right, in this section, they talk about solving linear equations. All right, solving linear equations, and these linear equations, some will contain fractions. So with fractions, and then you're going to solve rational equations. You're going to solve rational equations. Okay, so just recall from a previous course that a linear equation has this form: ax plus b equal c. 0, excuse me. Ax plus b equals 0. Ax plus b equals 0. So at some point, and you can see what's going to make it linear, but remember what makes it linear is that the variable, the exponent, is 1. So for example, here's a linear equation. 2x plus 1 equal 5. That's a linear equation. It's an equation because of an equal sign, and it's linear because the exponent of x is 1. Now last semester you also had a quadratic equation. What made it quadratic? The exponent was 2. So this is linear. This is quadratic. Okay, that would be quadratic. So you had that last semester. Remember last semester you dealt with the quadratic formula? You're going to see this again in another section as a review. All right, so this is linear, this is quadratic. In this section, in section 1.2, you'll be interested more with the linear part. So again, what make this linear? The exponent was what?
1.
1. This is quadratic because the exponent, the highest exponent is 2. All right, so let's go ahead and look at some examples. So let's solve number 1. Let's suppose we had 2 times 3x plus 1 equals 5 minus 3 times x minus 2. All right, so what's the first thing you're going to do in solving this linear equation? Use distributive property. So if you have any parentheses, you get rid of parentheses. So get rid of parentheses. Using the distributive property. All right. So you're going to say 2 times 3x is 6x. 2 times a positive 1 is a positive 2 equal. All right, now here's a mistake that some of you make on this side. You say 5 minus 3 is 2, some of you say first. But remember the order of operations. You got to do multiplication before you do what? Subtraction. So you have to distribute first. So in this case, distribute the negative 3. So this becomes 5 minus 3x plus 6. All right. So that was step 1. So step 1, if you have parentheses, get rid of your parentheses by using distributive property. Okay, once you're at this step, though, now also keep in mind that each of these equations are equivalent. So that original equation is equivalent to this one. It's going to be equivalent to the next one. So equivalent equations have the same solution. So we're trying to get to the point where we get x equals some number. That's what we're trying to get to. All right, so these equations are equivalent, meaning they're going to have the same solution. So remember, you're trying to solve the original. So you're doing some steps here, some processes to get to that point to where you can easily determine what the solution is. All right, what do you think the next step is? Combine like terms if you can. So step 2 would be to combine like terms. Can I combine anything on the left? No. So I'm just going to rewrite it. What can I combine on the right-hand side? Okay, what are those called? Constants. So 5 and 6 is 11. So you can say 11 minus 3x, or you can say negative 3x plus 11. Does not matter. All right, now when you're at that point, what's the next step when solving a linear equation? So you bring all the variables to one side, all the constants to the other. All right, so step 3, the idea is to bring variables to one side and constants to the other. Now remember, you're going to use the properties of equality for that. Using properties of equality. So bring the variables to one side, constants to the other, using properties of equality. And the property of equality you're going to use here is the addition property of equality. All right, so recall that the addition property of equality just means this. What you add to one side, you add to the other. So same thing for subtraction. Subtract 5 from one side, you subtract 5 from the other. So it's keeping the equation balanced. All right, and let's go ahead in this case and bring the variables to the left-hand side. It does not matter. So let's just bring them to the left-hand side. So let's start with the variables first. It does not matter whether you start with the variables or the constants. Let's start with the variable. On this side, which term has the variable in it? Negative 3x, not 3x, negative 3x. So what do I need to add to this to get it to that side? A positive 3x. So I'm going to add 3x to both sides. So as you're doing your worksheet, those who have had it before, notice that you got to do your work as it is presented in class. All right, because if it's not done as presented in class, you're not getting full credit. So some of you already know me by now about this. All right. 6x plus 3x? 9x. So, and remember, you can use a property of equality and also combine like terms. So you can combine like terms quite often. So that's 9x plus 2 equal, and then a negative 3x and a positive 3x is what? So what's left on the right? All right, so that's where we're at. Okay, so now I brought the variables to one side, now I'll bring the constants to the other. Subtract 2 from both sides. So what I do to one side, I do to the other. And then we combine like terms again. 2 and a negative 2 is 0, and you're left with what over here? Equal 9. All right. Step 4 now is to get the variable by itself. Yeah. Using the multiplication property of equality. All right. So there's no division property of equality, there's a multiplication property of equality only. So even though you're dividing both sides by 9 to get the variable by itself, it's still the multiplication property, because dividing by 9 is the same thing as multiplying by what fraction? Not 9, 1/9. 1/9. So you're multiplying both sides by 1/9, right? Okay, look. Isn't that the same thing as dividing by 9? Is multiplying by 1/9 the same thing as dividing by 9? Yeah, so it's called the multiplication property of equality. There is no division property of equality. There's only multiplication. So you divide by 9. 9 divided by 9 is what? 1. 1 times x is, that's a 1 right here. So what is x equal to? 1. So what is this 1? What's that called? Your solution. One's called your solution. So notice that all of these equations, see all these equations? They're all equivalent. So x equal 1 is a solution to this, 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 and it's a solution to the original. Okay, so these are all called equivalent equations. All right, so you use this process here, you use this process to get all these equivalent equations so you can get the variable by itself so you can determine the solution to the original problem. So equivalent equations or equations have the same solution. All right. Okay, let's look at another one. Okay, number 2. Number 2, suppose we had this one. 16 equal 3 times x minus 1 minus, in parentheses, x minus 7. All right, so let's see if you remember how to do this one. Okay, what's step 1? Yeah, I have parentheses, use distributive property. I'm going to use distributive property how many times? Twice. So over here, this part's easy because you can distribute everything in here by what number? 3. Now be careful here. What are you going to distribute here? Negative 1. Okay, there's no number there. It's understood to be a 1. All right. Okay, so get 16 equal, what is this part right here? Okay, now what does this become? Negative x what? Plus 7, because a negative 1 times a negative 7 is a positive 7. All right, so that was your step 1. What's step 2? Combine like terms. All right, so on the right-hand side, the left-hand side, there's just one term. Somebody's going to rewrite it. What's 3x minus x? What's a negative 3 and a positive 7? Positive 4. Okay, and then remember, we bring all the variables one side, constant to the other. This equation, remember all these equations are equivalent. This third equation you see, the variable's already on one side. So what do you think the next step's going to be? Subtract 4 from both sides. What you do to one side, you do the other. Then what's the next step? What's that called? Combine like terms. What's 16 minus 4? Equal? 2x. What's the next step? What property are you using? Multiplication property of equality. So you divide both sides by 2. So x equal 6. So that's your solution. Right. That's the solution to the original. All right, now remember, you don't have time to check on a test, but if you check it, if you check x equals 6, remember you're solving the original. You want to find the solution to the original. Go back and plug in 6 into the original. So here's the original. And so wherever you see the variable x, what do I substitute? 6. So I get 16. I want to see if that's going to equal 3 times 6 minus 1 minus, in parentheses, 6 minus 7. All right, remember the order of operations. So according to the order of operations, now remember, with order of operations, there is no distributive property. So actually use the order of operations. Please excuse my dear Aunt Sally. So you do what's inside the parentheses first. What's 6 minus 1? Okay, so that becomes 3 times 5 minus, what's 6 minus 7? Negative 1, so that's where we're at. Then multiplication. What's 3 times 5? So I get 15, subtract a negative 1. 15 subtract a negative 1 means the same thing as 15 what? Plus 1, which is what? Which is what I wanted. Okay? All right. Okay, now let's do one with a fraction in it. So these are going to be linear equations with fractions. All right, so linear equations with fractions. Okay, number one, we have 2x minus 3 divided by 2 equals 3/4 minus x plus 5 divided by 8. So 2x minus 3 divided by 2 equals 3/4 minus x plus 5 divided by 8. All right, so it's still a linear equation, because if you look at the exponent of x's, wherever you see an x, what is that exponent? 1. The denominator, it's okay, the denominator has a number in it. Those are all numbers. There's no variable in the denominator. It's just constants. So it's still a linear equation. It's not the kind of linear equation you want, because it makes it complicated, but it's still considered a linear equation. But since I do have fractions in it, what made the previous two easy was because there weren't any fractions. But I do have fractions here. So the first thing you're going to do, step one, just like you did before, is to clear the fractions. Clear the fractions. So you can clear the fractions by finding the LCD. So you can clear the fractions by multiplying both sides by the LCD. And remember, what does LCD stand for? Least common denominator. So if you look at all your denominators, what's this number right here? 2. What's this number? What's this number? What's the smallest? And it doesn't have to be the least. It could be a common denominator, but always use the least. It makes things easier in yourself. What's the smallest number that 2, 4, and 8 go into? 8. All right. So what you're going to do now is this. You're going to multiply both sides by 8. Now, by multiplying by 8, all these denominators will become 1s. That's the whole point. You want these to be 1s instead. All right. Now, here's what's going to happen as well. How many fractions do you see on the left side? How many do you see on the right? 2. Altogether, how many fractions? 3. So you're going to need to put the right-hand side in parentheses because there's more than one fraction. Because remember, you're going to multiply both sides by the LCD, meaning this. I'm going to rewrite this over. I'm going to leave a little bit of space here. So all I did was just rewrite the problem over with some space. Okay, so if I want to get rid of this denominator 2, if I want to make this a 1, I've got to multiply by the LCD. And what's the LCD? 8. What I do to one side, I have to do to the other, just like you did in the previous problems. But I'm going to put this in parentheses because both of these have to be multiplied by what? 8. All right, so that's where I'm at. The rest now are the steps from the previous problem. So now use steps from before. Okay, have parentheses. What's the next step? Distribute. Use distributive property. So I'm going to rewrite this over right here. Now, some of you may want to skip a step. You may want to reduce now. That's okay. But I'm just going to go ahead and rewrite it over. Because all I want to do is just use the distributive property at this point. So 8 times 2x minus 3 divided by 2 equal, I'm going to distribute, right? Because everything here has to be multiplied by what? 8. So you're going to say 8 times 3/4 minus 8 times what? X plus 5 divided by 8. So that's where I'm at. So all I did was use distributive property. Now here's where else you have to be careful now. So remember, the whole point of multiplying by the LCD is to make these denominators what? 1s. So to do that, you multiply by the LCD. Now you're going to reduce. 2 into 2 is 1. 2 and 8 is 4. Okay, now you got to be careful. If you're not careful, you're going to say 4 times 2x is what? 8x, and you're going to say this is 8x minus 3. It is not 8x minus 3, it is what? 8x minus 12. Everything in the numerator has to be multiplied by what? 4. So at this point, what I would do is I would put this in parentheses. Put the numerator in parentheses. If it's more than one term, put it in parentheses. If you look at this next fraction right here, how many terms are in this numerator? 1. I'm not putting in parentheses. If you look at this next fraction right here, this numerator, how many terms are in this numerator? 2. I'm going to put this in parentheses. So notice, as you're doing the problem, we're inserting parentheses to help us with the process of finding the solution. Okay, and then you're going to say 4 into 4 is 1, 4 into 8 is what? 2. Then you're going to say 8 into 8 is 1, 8 into 8 is what? 1. Okay, good. So this is where I'm at. So if you kind of look at this, this is what you have right now. You have 4 times what? 2x minus 3 in parentheses equal 2 times 3 is 6. Minus 1 times what? That's what you have. And now that looks a lot easier than what you've had before. What's the next step, do you think? Distributive property. So 4 times 2x is 8x. 4 times a negative 3 is a negative 12, equal. Now, are you going to say 6 minus 1 is 5? No. You got to do what first? According to the order of operation, you have to do what first? Multiplication. So to do that, you can use your distributive property. So notice if you had not put that in parentheses, some of you would have said this is negative x plus 5, and it's not negative x plus 5. It is what? Negative x minus 5. So that's why putting these in parentheses, putting these numerators here in parentheses is important. Because that constant in both cases would have been wrong for some of you. So that's 6 minus x, and then what? Minus 5. Okay, what do you think is the next step? All right, I can only combine like terms on the right-hand side, so I'm going to rewrite the left. Okay, that's going to be negative x what? Plus 1. All right, so that's where I'm at. So notice all of these steps, all of these equations are equivalent. There's no way you could have looked at this equation and told me what the solution is. So using these steps here to get to the point where you're going to get to an equation that's going to say x equal a number. And then that will be the solutions to all of these. Okay, what's the next step? Okay, what do you want to do first? Add x to both sides, all right. What's 8x and x? Minus 12 equal, this is 0. What's that equal to? 1. All right, we're going to rewrite this over here. What's the next step?
Add 12 to both sides.
So when I combine like terms, I get 9x equal 13. And then finally, what's the next step? Divide both sides by 9, just like you see it. 9 divided by 9 is 1. 1 times x is x. What's x equal to? 13 ninths. So that's your solution. So x equals 13 ninths is a solution to this equation. It's a solution to this equation. It's a solution to this equation. It's a solution to this equation. Because all these equations are called what kind of equations? Oh, I mean, they're all linear, but they're equivalent equations. They're all equivalent, meaning they have the same solutions. And we're not going to check that because it's a fraction. So I'm not going to spend the time of doing that one. All right. So let's do one more with fractions in it. So there's number 2. All right, x plus 3 divided by 3. minus 1 equal 3 halves plus x minus 5 divided by 6. Is this a linear equation?
Yes.
Yes, because the variables have what exponent? 1. Does it matter that there are numbers in the denominator? No, it's still linear. So notice when we did this, when we looked at the original here, we ended up with, see how these are all equivalent, so these are linear? All right, what's the first step to solve this linear equation? Find the LCD. Now, how many fractions do you see altogether? 4. 4. There's this one. There's this one, which you can say negative 1 over what? 1. There's this one, this one. So if you look at your denominators, this is 3. This denominator right here is what? 1. This is 2. This is 6. What's the LCD? 6. So the smallest number that 3, 2, and 6 go into is 6. Could someone have used 12 as a common denominator? Yes. So any number divisible by 6 would have worked. But always use the least. It makes things easier in yourself. All right, once you find the least common denominator, what's the next step? Multiply both sides by the LCD by 6. Now, since both sides had more than one fraction, I'm going to put both of them in parentheses. So x plus 3 divided by 3 minus 1 equal, and then 3 halves plus x minus 5 divided by 6 in parentheses. And all I do now is multiply by 6. Multiply this by 6, multiply this by 6. So notice I did insert some parentheses. Now I have to get rid of these parentheses. How are you going to get rid of the parentheses? Distributive property. All right, now you get some of you, when you had these last semester, so what some of you did was you said this, and this is where you messed up. You said 3 into 3 is 1, 3 into 6 is 2, and distribute the 2, but that's incorrect. You got to distribute it what? 6. Because if you distribute the 2, 2 times negative 1 is negative 2, right? But that really, what do you think that's going to be? Negative 6. So don't reduce now. All you do now is distribute. So you got to be careful. So 6 times x plus 3 divided by 3, right? Now at this point, what might you want to do with this numerator? Put in parentheses. Minus, and then 6 times what? 1. Equal, and then this is going to be 6 times what? 3 halves. Do I need to put this 3 in parentheses? No. Plus, and then 6 times what? X minus 5 divided by 6. Put the x minus 5 in parentheses. All right. Now we're going to reduce. So I'm reducing at this point. Meaning this. Remember, the whole point of multiplying by the LCD is that these denominators are become what numbers? 1. So you say 3 into 3 is 1. 3 into 6 is what? 2. 2 into 2 is 1. 2 into 6 is what? 3. 6 into 6 is 1. 6 into 6 is 1. Now, if you look at what you have, if you rewrite what you have 2 times what? X plus 3 minus what? 6 equal? 9, good. Plus 1 times what? X minus 5. All right, and now you're going to use what property? Distributive property, get rid of the parentheses. What's 2 times x plus 3?
2x.
6, and then minus 6 equal, are you going to say 9 plus 1 is 10?
No.
No, you're going to say 9 plus, and then distribute the 1, but that's still going to be what?
X minus 5.
X minus 5. Okay, what's the next step? Combine like terms. What do you get on the left-hand side? 2x only, because 6 and a negative 6 is 0. Equal? That's going to be x what? Plus 4. What's the next step? Subtract x from both sides. And then combine like terms again. What's 2x minus x? Equal? This is 0, so what's x equal to? 4. That's called your solution, right? That's the solution to the original problem. So x equal 4. And you can, and since that's a nice number to deal with, you can check if you want to. Check x equal 4. Go back to the original though. So you have x plus 3 divided by 3. Subtract 1 equal 3 halves plus x minus 5 divided by 6. So wherever you see the variable x, would you substitute? 4. What's 4 plus 3?
7.
So that's 7/3, right? Minus 1, and you want to see that's going to equal 3 halves plus, and then that's 4 minus 5 divided by 6, which is what? Negative 1/6, right? Okay, what's 7/3 minus 1? What fraction is that? Huh? 1 1/3 or 4/3, right? Over here, what's the LCD? So I'm right, with two fractions with 6. 2 times what is 6? 3 times 3 is 9. This already is 6, so that's going to be a negative 1. What's 9/6 plus the negative 1/6?
8/6.
Is 8/6 the same thing as 4/3? Yes, because what's 8/6 reduced? 4/3. Okay. All right, so that should give you, let me go ahead and pause this.